Hello everyone, welcome to all in this video lecture series of Database Management System. I am Deepak Aneja, Assistant Professor, ABES Engineering College, Ghaziabad. In this video, we will cover the topic canonical cover or minimal set of functional dependencies. This is very important topic at the exam point of view. So let us start this topic. Canonical or minimal set of functional dependencies. If we have a set of functional dependencies, we get the minimum set and irreducible form of functional dependencies after reducing these functional dependency. This is called the minimal cover or irreducible set, as we cannot reduce the set further or canonical cover. Let us understand the procedure to find the minimal cover with an example. So what we have to do, this is the functional dependency set that are given. We have to find the minimal functional dependency set that will cover all these functional dependencies, or that will preserve all the given functional dependencies. So what is the procedure to find the minimal set or canonical cover? So there are total 3 steps. Step number 1. So in this, we have to first decompose the right hand side attributes by the law of decomposition or decomposition axiom. So now the FD set is B determine A, AD determine BC. Now AD determine B, we have to decompose this right hand side. Now AD determine C. Now C determine A, C determine B, C determine D. Remember, we have to decompose the attributes given in the right hand side, not in the left hand side. The first step is we have to decompose the right hand side attributes by the law of decomposition, as we have already studied. Now, the step 2. In the next step, we have to remove the redundant functional dependencies. Redundant means one by one, we will remove each functional dependency and then check, is it preserved by the remaining functional dependencies? If we can preserve this, we can hold this functional dependencies through the remaining functional dependencies, then we can remove this. Otherwise, we can't. So what is the procedure to check this? Remove the redundant. So first, we will remove B to A. B determines A. Now, take the closure set of B from the remaining functional dependencies. Remaining are these functional dependencies. So from B to B, we can determine. Now, from B, we cannot determine anything else. So we cannot determine A from B. So we cannot remove this functional dependency. Now check for second. Now remove. Now, sorry, check for AD to B. Now we can remove this. This is the part of functional dependencies. We can't remove this. Now take the closure set of AD from the remaining functional dependencies. From AD, we can determine AD to C, we can determine from C to A is already in the set. C to B, we can determine B to A already, C to D is already. So AD to B. So we can determine AD to B. We can determine from AD to B. So we can remove, we will remove, we will remove this FD. Now the new FD set is B determine A, AD, so AD determine C, now C determine A, C determine B, and C determine D. Now check for AD determines C. Now check for AD determine C. Now take the closure set of AD, AD from AD from D to, so we cannot determine AD to C. We can't determine. So we cannot remove this. Now check for, now check for, this is the part of function. Now check for C determines it. Now take the closure set of C. Now C determines C. From C, we can determine B, or from C, we can determine D, and from B, we can determine A. So from AD, we can determine C. So from this, we can determine A. We can determine. So we will remove this functional dependency. Now, the new FD set is B determine A, AD determine, AD determines C, C determine B, and C determine D. Now, now check for C determine B. So we'll remove this. Now take the closure set of C. From C to C, we cannot determine anything. C to D, but we can't determine B. So we cannot remove this FD. So now check for C determine D. This is the part of FD. So we can remove this. Take the closure set from the remaining FDs. C to C, from C to B, B to A, from AD to C. So we cannot determine C to D. We cannot determine C to D. So we cannot remove this FD. Now the final FD set after step 2, B determine A, AD determine C, C determine B, and C determine D. Now step 3. Now check for left hand side FDs. Now this. Now take AD determine C. Now take the closure set of AD from the given functional dependencies set. Now take AD to AD we can determine, AD to C we can determine, from C to B we can determine, or C to D, D is already in the list, or from B to A. Now check for single A closure set and D closure set. Now take the closure set of single attribute. Now from A we can determine A we cannot determine anything else. So from D closure set, D to D, from D we cannot determine anything. So this is not equivalent to this FD set, or this is also not equivalent to this FD set. So we cannot further decompose this FD. So the final minimal cover is minimal set, or you can say canonical cover of the given FDs are B determine A, AD determine C, or C determine B, or C determine D. Finally, you can write this as B determine A, AD determine C, and C determine BD. So this is the minimal set of functional dependencies that will cover all the given functional dependencies. This is the final answer. Now let us take one more example. The given FD set of R, V determine W, VW determine X, Y determine VXZ. Step 1. Now decompose right hand side attributes. So the key functional dependencies are V determine W, VW determine X, Y determine V, Y determine X, and Y determine Z. Now step 2. Remove the redundant functional dependency. Now first check for V determine W. Now remove this. Now take the closure set of V. V to V we can determine. From V we cannot determine anything. So can't determine. So cannot remove. Now this will be the part of. Now check for VW determine X. Take the closure set of VW. From VW we can determine VW. From V we can determine W. No more attribute comes in this attribute closure. So we cannot determine X. So cannot remove. Now check for this Y determine V. Sorry. Y determine V. Now take the closure set of Y. Now from Y we can determine Y. From Y we can determine X. From Y we can determine Z. Or uh, Y we cannot determine anything else. So we cannot determine V. So we cannot remove this. Now check for Y determine X. Now take the closure set. Y, from Y we can determine V, or from Y we can determine Z, or from V we can determine W, or from VW we can determine X. So we can determine X. So we will remove this. So final FD set is V determine W, VW determine X, Y determines V, and Y determine Z. Now check for Y determine Z. Take the closure set of Y. So from Y we can determine Y, or from Y to, so this is removed. Y to V we can determine, from V to W, or from VW to X, but we cannot determine Z. So cannot remove. So final FD set is we determine W, VW determine X, Y determine V, and Y determine Z. Now step 3. Now check for left hand side attributes. Yeah, you can say redundant attributes. So here is VW determine X. Now take the closure set of VW from this functional dependencies. So VW we can determine, from V we can determine W, VW we can determine X, or we cannot determine anything else from this functional dependencies. Now decompose this V and W. Now take the closure set of V. We can determine V, from V can determine W, and VW to X. This is equivalent to, this is equals to same as of VW, closure set of VW. Now take the W, closure set of W. W we can determine, we can't determine anything else. So both are same. So we can write V instead of VW, because V can hold, we can hold or preserve all the attributes determined by VW. So the final minimal cover is minimal set of FDs, or canonical cover is V determines W, V determine X, Y determine V, and Y determine Z. We can write this as V determine WX, or Y determine VZ. So this is our final minimal cover set or canonical cover. So these are the references for this video. Thanks for watching this video.